Okay, let's take a look at 2025 AP Calculus AB BC question 4 non-calculator question. There's an image in this graph, in this question we're not going to share at the request of the College Board, but we are told that g of x is defined as an integral of function f of t. First question up asks us to find g prime of 8, so that would obviously require that we understand that g prime of x, right, is equal to f of x. And so really all this question is looking for is the value of f of 8. And so I have that as 1. And they do ask in the question, give a reason for your answer. So this would be an application of the fundamental theorem of calculus. We want to mention that. Question B asks to find all points of inflection on the graph of g inside the open interval -6 to 12. Okay, so g is going to have a point of inflection wherever we see, right, the second derivative of g, which is really the first derivative of f in this problem, change sign. Okay, and on the graph we're only going to see that happen at x equals plus or minus 3. And really, again, if we're looking to justify that, we're going to say something like this is where on the graph of f we see the function itself change from decrease to increase or vice versa. You can also refer to slopes of tangent lines if you like. Question C asks us to find two values, the values of g of 12 and g of 0. And both of these are going to involve some form of integration here. So g of 12 is just going to be the integral from 6 to 12 of the given graph, the function we have. And in that case, it's really just a triangular region. That will end up being 9. And then g of 0 is going to be the integral from 6 to 0, right? And so obviously the boundaries here, the limits of integration are backwards, so we'd have to switch them. So this is the same thing as saying this. And in this particular example, we were finding the area of a half circle, but of course we have to incorporate that negative. Final answer there should be -9 pi over 2. Okay, switching gears to question D. D asks to find any absolute mins of g on the closed interval -6 to 12. And so in order to do that, again, we're going to have to look at not only g of -6 and g of 12, but we're also going to find any possible critical value inside that interval. So if we look, for instance, at -6, well, the integral from 6 to -6, right, is actually just going to wind up being 0. The integral, oh, I'm sorry, yeah. And then g of 12, I'm sorry, is going to be the integral, right, from 6 to 12. And that was 9 from our previous part up here in part C, right? And then the only other thing we need to do is look for a critical value. So in other words, where is g prime equal to 0? Right, well, g prime is going to equal 0 wherever f equals 0. And that could only be possible at 0 or 6, right? And they're looking specifically for a min, and so really that really says we only need to look at 0, because on the graph there was actually no change from positive to negative on at x equals 6. So we now need to go get the value of g of 0, which is the integral from 6 to 0, which we got back in part C as well, and that was -9 pi over 2. And so looking for the absolute minimum, right, it asks find the value of x where that happens. So the correct answer would be absolute minimum at x equals 0. So there's question 4. In some other videos we'll tackle question 5 and question 6.